should we protect endangered species? Is the cost of protecting endangered species greater or less than the benefit to society of preserving endangered species, et cetera, et cetera? These are normative questions, right? Normative economics begins with placing values on things and then comparing those values and saying what's better and what's worse. When you relax these various different things that we call rationality assumptions, in this case, the assumption of rational preferences, you typically, well, in the cases we really care about, because they define behavioral economics, you typically improve prediction, and then often really complicated and unpredictable things happen with normative economics. Let me give you a couple examples. So I just talked about cost-benefit analysis of, say, protecting endangered species. Cost-benefit analysis is explicitly about measuring people's willingness to pay for various different impacts of public policy, which may be positive or negative. So if we decide that we're going to protect the wolves outside of Yellowstone Park, there are going to be people who will have a positive willingness to pay for preserving the species, and they will say, that has a positive impact on me, and then we want to know what is the dollar value of that positive impact, either per wolf or per species or whatever. And it's going to have a cost on the ranchers around Yellowstone National Park because the wolves going to kill their livestock and, terrify their children, et cetera, et cetera. Okay? And those people would potentially be, able to state their willingness, what is your willingness to accept payment in exchange for having wolves kill your livestock and terrify your children. Okay? And then we would add all that up, right, multiply the willingness to pay by the number of wolves and the number of ranchers and the number of environmentalists and the livestock that get eaten, and compare the pluses to the minuses. That's cost-benefit analysis. You've done it in 100A when you compared you look at, okay, so we're going to impose a tax, say there's a monopoly, right? So there's benefits to the monopolists because they get all this extra rent, and then there's harm done to the consumers because they lose all this consumer surplus, and then there's the dead weight loss, which is also a cost to society. You add those things up, it comes out big time negative, even though there are benefits to the producers. You just did cost-benefit analysis, okay? The reason that that's straightforward in a market situation is that you have prices to tell you what people's willingness to pay is. People don't typically trade wolves. And they certainly don't, well, sometimes they do trade habitat for wolves, but usually they're not thinking about it in terms of the value of the habitat for the wolf, they're thinking about it in terms of the value of the ranch land for the farmer. So the actual value that people place on preserving species, in this case wolves, doesn't show up in market prices. And there are clever ways that you can try to back it out from like, okay, well, what's the willingness of environmentalists to pay extra money for a house close to a wolf, okay, compared to a house that isn't close to a wolf, and people do that kind of stuff a lot. But the main way that people try to put a willingness to pay on non-traded goods like endangered species is through what's called contingent valuation surveys, okay? And we talked about this because you saw a bunch of results from them last time in that table. Where you just ask people these hypothetical questions. And there's several decades of refinements to the design of these surveys to make them more convincing and more believable, to make the hypothetical scenarios seem more real, to try to convince people that the cost that's going to be imposed on them is going to be a real cost. Like, what is that? So wait, are you going to actually collect the money from me? Yes, we're going to impose the following tax structure on you, that kind of thing, okay? And sometimes people actually try to do this where people actually will be paying the tax, right? So they really better get the answer right. So there's, we can argue about whether or not the surveys themselves are legitimate tools for eliciting willingness to pay or willingness to accept, but I feel that they're not completely legitimate from the standpoint of survey design. There's a lot known about effective survey design. The question is whether or not there's a problem with the difference between willingness to pay and willingness to accept in these surveys, because you've seen already in the last lecture that the difference can be vast, really sort of crazy big. Okay? And they're used a lot. And they're actually used to determine whether or not policies will be implemented or not, in a pretty significant and meaningful way. If we allow ourselves to assume that people's preferences for these non-traded goods are rational, right? So that, for example, the endowment effect is ruled out, okay? Then we get to treat either willingness to pay or willingness to accept as appropriate estimates of the actual social benefit of the goods, and therefore to help use those things confidently to determine whether or not to impose a certain policy, right? Now, and then if you say, well, there are income effects, because if people say the wolf is worth $100,000 and giving them a wolf and listing their willingness to accept means that they're on a different curve, that's fine. All we have to do is to determine, does this policy what's the actual effect of the policy? Does it involve giving people wolves and taking them away, or does it involve giving them, in other words, which indifference curve does the policy actually put them on? And then if it puts them on the lower indifference curve, we'll use willingness to pay. If it puts them on the higher indifference curve, we'll use willingness to accept. No problem, okay? But if you assume that there's reference dependence, which means rationality is going to break down, then it really becomes quite unclear whether we should be using willingness to pay or willingness to accept. And the difference can be the difference between saving the wolves and not saving the wolves. Indeed, the difference could be the difference between imposing cap and trade for carbon emissions and not, because these numbers get really huge. Jack Netsch says you should take the endowment effect seriously. If people say that if people say that loss matters more than gain, right? If you do some empirical study and you find that people's value function looks like that and there's a kink there at the reference point, if your policy involves taking away something people have already got, you should take seriously the fact that they say that matters more to them than policy that involves giving them something they don't already have. So that if your policy involves taking away wolves that already exist, you should use willingness to accept, and you have to just deal with the fact that that's a huge number. And if your policy involves adding wolves that don't currently exist, then you need to take seriously the fact that people don't care that much about gaining a wolf relative to their reference point, and that policy is not worth as much as the policy that protects them, the ones that already exist. That's Jack Netsch's position. Okay? Here's the problem with that. We've already seen, so how many months do you have right now? 1, which I think is actually a reasonable number of months for a person to have. You live alone? Okay, so you only need 1 month, so that's the right number of months to have, in my opinion. So his reference point right now we would expect is 1 mug, right? And if I ask him his willingness to accept payment in dollars in exchange for taking that mug away, Jack Netsch would say, he's going to experience loss aversion, take that number seriously. But we've already observed the following thing. If I give you a mug, within 5 minutes, your reference point is going to change to 2 mugs. If I then have a policy that involves taking a mug away from you, how quickly do you think your reference point is going to go back to 1 mug? It might take a little longer. Would you believe a week? Would you believe a month? You've only had the mug for 10 minutes. A month from now, do you remember what I said a week ago in this lecture? Some of it. You may not even remember the mug in a month. It's not believable that these reference points stay fixed forever. We know that they don't. We know that reference point adaptation is a big deal. Sometimes it happens surprisingly fast. Sometimes it takes longer. If you won the lottery and you suddenly become a millionaire, it may take some time for you to adjust to the idea that you're a millionaire, but it will happen. Okay? So should we really take seriously people's crushing feelings of loss aversion if we know that they're going to get used to the loss? I don't know the answer. We'll address it when we start talking about projection bias in a few weeks after the first after the first midterm, but it's a major problem. It's a major problem in cost-benefit analysis. And because Ronald Reagan made it law that all federal policies have to be subjected to cost-benefit analysis, and since every president since then, including Barack Obama, has affirmed that, it matters. Okay, enough about contingent valuation. Now what are you doing to me? There we go. Okay, here's another example. Normative implications of the endowment effect, or the breakdown of rationality in the case of the endowment effect. How many of you are familiar with the Coase theorem? Okay. How many of you who just raised your hand are from the business school? Okay, probably a different Coase theorem. He has two. There's one about what defines the boundaries of the firm. Is that the one you know? Sorry? You know both. Okay, well, that's the business school for you. The Coase theorem that I'm interested in is the one that Neckar writes about, that you may have covered in 100A, that has to do with externalities. Right? An externality is when something that I do has a positive or negative impact on somebody else other than the person I bought the thing from. Right? So it's external to, it's an impact of somebody's activity that is external to the market transaction. Right? So if I produce a kilowatt of electricity, the buyer gets a positive impact, but they also pay for it. So that's not an external benefit. But if it causes pollution and the degradation of forests and global warming, et cetera, that's a negative impact that nobody's paying for or receiving money for. That's external to the market. Okay? So we also talk about this as a missing markets problem, because there should be a market for that clean air that I used up when I was making that kilowatt of electricity, but that market doesn't exist because there's nobody on the other side of the market to trade with me, because the trees don't use dollars, and neither do future generations. Okay, the Coase theorem says, when you have an externality, roughly what it says, is that when you have an externality in a market, when there's an externality to some market trade, that as long as you assign the property rights for that external impact clearly, and then defend those property rights legally, it doesn't matter who you give the property rights to. So here's the classic example. This is actually one of the examples that Coase cited in his famous paper, which is on B-Space. You got a swimming pool, and somebody wants to build a building that's going to cast a shadow on the swimming pool. Okay? So imagine the building, let's say, belongs to an individual who is a rental housing investor, and they earn net revenue profit per story, right? However many stories they build it, they get a certain amount of profit per story. And let's say that the profit to this individual who's an investor is $100 or $100,000, something like that, per story, where S is the number of stories in the building. But then that's going to cast a shadow. And let's just say, for the sake of simplicity, that that every story adds an hour to how long that shadow falls on the swimming pool. Yeah? Okay? And then there's a cost to that. The swimming pool belongs to some club. The members of the club really like to hang out in the sun, but they have diminishing marginal utility for hours of sunlight, which means that they have increasing marginal cost for shade. So let's make H, so we'll call this sort of the utility cost. Cost in utils. Well, no, it's the dollar value of the utility cost. So what do we want to call this? This is the disutility will be equal to, let's say, 10 times h squared, where h is the number of hours of shade that they have to endure each day. And we're going to make the simplifying assumption that every story adds an hour of shade for these poor people's swimming experience. Right? What we want to know is, what is the socially optimal height of the building? Okay? Benefits to society in the form of profit here. Cost to society in the form of disutility here. Net social benefit is the benefits minus the cost, and we want to maximize that. Okay? So we want to do maximize 100s, that's the benefits, minus, now I'm going to substitute s for h here, 10s squared. First order conditions, you just take the first derivative of that, and what you get is s equals, right, the first order condition is the first derivative has to equal 0. You change the minus sign into an equal sign, and you get s equals 2 times 10 times, sorry, not s, 100 equals 2 times 10 times s, and that implies that the socially optimal height of the building is 5 stories. Why? Because that is the height at which the marginal cost to the swimmers of adding one more story is equal to the marginal benefit to the property owner of getting more profit from adding stories. Okay? What Coase said, Coase is, so this is, the first order condition is that the marginal cost has to be equal to the marginal benefit. Okay? What Coase pointed out was this. If you give the property right to the airspace above the right to build, the airspace above the investor's land to the investor, then in order to get utility out of their swimming pool, if that property right is well defined, the swimming pool owners will have to pay the apartment investor to say, well, don't build this, for how many stories they want not build, they'll have to pay on a per story basis, yes? They will be willing to pay for every story that imposes a marginal cost on them in terms of extra shade that is greater than, sorry, let me back up. It's not a question of how much they're willing to pay. The question is, what's the guy willing to accept? The investor, the apartment builder, will be willing to not build any story for which the willingness to pay of the pool owners is greater than his or her revenue from adding another story, right? Well, the revenue per story is $100. So every story, right, for the first story, these folks are only getting, so the marginal cost here is equal to 20s. So if the first story is only getting $12, because they don't care that much about the first hour of shade. Second hour of shade is $40. The fifth hour of shade is worth $100. So that's the equilibrium point. If he builds a sixth story, the marginal cost of that story to them is going to be $120, and they'll be willing to pay him $120 and not build it, and he will say, fine, I'm better off not building it than building it. And if we give the property rights instead to the swimmers, then the builder has to pay them for every story that he builds. Okay? And they will be willing to allow him to build every story for which his willingness to pay is greater than their cost. And if you do the math, you very quickly will see that he's going to be willing to give them $100 per story, and they will accept that for the first 5 stories and no more. So you get the socially optimal result no matter who you give the property rights to, which means that all you crybabies who care about environmental justice can just go home and focus on property rights. Right? That is how the Coase theorem is used politically. Under the assumption of rational preferences, if you can in fact define property rights clearly, and if you can in fact create a market in which people can make those trades effectively, and unless there are huge income effects, which there typically aren't, that's correct, and it's fine. But in the presence of the endowment effect, we have an additional problem. Okay? Oh, I should also say that I just said income effects are usually not a big deal. They're a very big deal if the swimmers are actually really poor, because then their dollars are worth a lot more to them, and cost-benefit analysis becomes biased when the Coase theorem starts to break down, because they don't have the money to pay. Their money is worth so much more to them that they're not. They might. Yeah. So you do run into big problems when the people on either side of the transaction have radically different incomes. But under reference dependence, there's an additional problem, and a much more basic problem, which is that if the person that you give the rights to is suddenly going to, their reference point is suddenly going to, whoop, now I have property rights. That's part of my endowment, that's part of my reference point. You better not take it away from me because I'm going to experience loss aversion. Now, if you give the property rights to the building owner, and the swimming club has to buy them away, and the investor over here, the builder, is like experiencing loss aversion for every story's worth of property rights they have to give up, their willingness to accept is going to be inflated by loss aversion. And if you give the property rights to the swimming owners, and you say, well, no, we have the right to sunshine, we have loss aversion when we give up an hour of sunshine, and you're going to get dramatically different optimal heights for the building. And the coast theorem just becomes completely wrong. And so again, it comes down to whether or not you're going to take those reference-dependent preferences seriously. Was there anything else on this slide that I wanted to say? No. Okay. How am I doing? Okay. Quickly, because I want to move on and talk about John List's research. Just some other places where reference dependence shows up, just so you know it's not just all about mugs and swimming pools and wolves. This is one of my favorites, and this paper is on the website, and it's brilliant. You should really give it a look. The Easterlin paradox, which was observed back in the early 70s, I think 1974, is that this guy Easterlin observed that since World War II, he mapped out the growth in per capita income for all these different countries, and he looked at survey results on people's satisfaction with their lives, and he found that there's absolutely no correlation between income and happiness. Beyond subsistence income, which he put somewhere around $10,000, okay? I think in current terms, in now dollars. So beyond subsistence level, more money apparently doesn't make people happier, and yet they spend much of their time fighting for it. The paradox gets worse because it turns out that income distribution, where you are in the income distribution within a country, does matter to your happiness, but over time, growth in per capita income doesn't increase national happiness. So there's a real paradox here. There are a couple of different ways that you can explain this using reference-dependent preferences. If people's reference point is last year's income, then what's happening is that they're constantly feeling like they need to do better by earning more income. But if their reference point is continuously adapting over time, then they're sort of they're in what's called a hedonic treadmill, and they're constantly just in a race against the adaptation of their own reference point. And they're never more than one knot, right? In other words, if you're doing this all the time, right, and it doesn't even matter, the kink doesn't even matter anymore. Here's your reference point. That's last year's income. You're doing better this year, so you're happy. And what we'd like to believe is that if you're doing better next year, you're even happier. But what's happening is that the axis is chasing you. Right? The reference point is chasing you. So next year, you're actually not there, you're actually here. Okay? And then if another part of your reference point, or if we define your reference point differently and say, well, maybe people's reference point is how much their neighbors are earning, right? Keeping up with the Joneses. In which case, and the way that this is modeled in the paper that's on the website is, what if your reference point is actually today's per capita income for your society? So you want to know whether you're above or below the average. Or it could be the median, or it could be like the average of just the people you see on television. Who knows? Then if you're above that, then you're going to feel happy, and if you're below, you're going to feel miserable. Okay? So then you would see a relationship within country, but not over time. Okay? And then that would suggest that actually increasing income distribution, or at least the perception of increasing income distribution, if you happen to display it all the time on television, could really be lowering national happiness levels. Okay, what else? Consumption income covariance and the permanent income hypothesis. That probably sounds like gibberish to most of you. There's this idea, particularly in macroeconomics, and this is very much a Chicago school idea, that people make consumption and savings and labor supply decisions not based on today's income or even this year's income, but on the entire lifetime span of their income, right? So that if my wage goes up now, I shouldn't be responding in my consumption choices to that entire increase. I should be spreading that increase out over my entire life because I can borrow against it or I can save it for later consumption. So the amount of that increase that I should experience now is relatively small, right? So my consumption should go up a little bit, not by the whole amount, okay? And the covariance between people's this year's income and this year's consumption turns out to be just way higher. When people's income goes up, their consumption goes up right away. When their income goes down, their consumption goes, and it's just the covariance is way higher than the permanent income hypothesis can explain. There's a paper online on the BSpace site that uses a reference-dependent model where the reference point is your current expectations of your future income. And what they find, which they've been able to observe in a very interesting data set, is that what happens is that when people's expectation of future earnings goes up, right, they start spending more now. This is like next year's union contract is what it's based on. And when there's an expectation of a loss next year, their income's going to go down because of the wording of the contract that their union just negotiated that's going to go into effect next year. You would expect that their spending would go down currently as well. It doesn't, right? Because to cut their spending now would be a loss in consumption, and they say, no, thank you very much. I'll deal with that later. I don't want to deal with that right now. Okay? So loss aversion causes this weird asymmetry in how people in the consumption income covariance that can potentially explain some of the anomalies that we see that can't be explained by the permanent income hypothesis. Incentive-based labor contracts. You've probably noticed. So we talk about capital and labor as inputs to production, right? And we talk about the price of labor is the wage, and the price of capital is R, right? Which stands for interest, which starts with an I. Real could be real interest. It's never been clear to me what it stands for. I think what it stands for is rate of return. But what is it actually? Is it the actual profit that you make on your investment? If I actually buy stock and then I get some big fat dividend out of it, is the dividend my payment for supplying, is that the price of capital? No. The price of capital is the amount of money, the minimum amount that I would have needed in order to convince you to make the investment in the first place. Normal profit. Which should have given you shivers when you learned it in 100 Day because it's an extraordinarily nebulous concept, right? It is completely undefined and it is unobservable. Because people never get paid normal profit, they get paid the actual profit. Investors receive economic profit. Their payment, capital's payment, is stochastic. It's based on, you don't know how much you're going to get, but you're going to get whatever, if the business is a success, you're going to make a lot, and if it's a failure, you're going to make not much.